Welcome back. This is Mrs. Rewrite with Advanced Algebra, and today's lesson is 1.6, Solving for a Variable. All right, so let's look what we got here. So a literal equation is an equation in which the coefficients, those are the numbers in front of letters, and the constants, just numbers, have been replaced by letters. In the following Explorer, you will see how a literal equation can be used to represent specific equations having the same form. Okay. Understanding literal equations. For each equation below, solve the equation by writing two equivalent equations. One where the x term is isolated, and one where the x is isolated. All right, so on this first one, what are we going to do? So if we want the x term to be isolated, so we want the 3x to be by itself. What do I do to get rid of that plus 1? I subtract 1 on both sides. So I'd have 3x equals 6. That's equivalent to this, right? Solved for the 3x. Now what if I wanted to solve for just x? I would do what to both sides? Divide by 3 on both sides, leaving me with x equals 2. So all three of these are equivalent equations, right? How about here? If I wanted that 2x to be by itself, I have to do what? Subtract 5 from both sides. And then to get x by itself, divide by -2 on both sides. So all three of those equations are equivalent equations. Get 4x by itself. 4x equals what? Subtract 3 on both sides. -1 minus 3, or -1 plus -3 is -4. Get x by itself. You divide by 4 on both sides. X is -1. Is everyone with me so far? Yes? Okay. Identify the two properties of equality that you used in Part A. List them in the order that you used them. So what did I use? I subtracted first, right? Subtraction, property of equality. And then what? Division, property of equality. Each equation in Part A has the general form ax plus b equals c, where a is not equal to 0. Solve this literal equation for x using the properties of equality that you identified in Part B. So if you had ax plus b equals c, if you were solving for ax, you would subtract b from both sides, which would leave you with c minus b. And then when you divide both sides by a, you would have c minus b all over a. So the literal equation, instead of it looking normal, like with numbers, right, this looks way more normal. This is going to be all letters, but you still follow the same rules. It just looks scary. Show that the solution of the literal equation gives the same solution of 3x plus 1 equals 7 as you found in Part A. Recognize that when a is 3, b is 1, and c is 7, the literal equation gives you the specific equation 3x plus 1 equals 7. So where's our literal equation? It was c minus b over a. If we were plugging these values in, c is 7, b is 1, and a is 3, 7 minus 1 is 6, and 6 over 3 reduces to 2. So we got the same answer. Right? And that shows you that it works because we followed the rules. Why must the restriction a is not equal to 0 be placed in the literal equation? You guys see here? You're dividing by a. Can you have a number like 6 over 0? That's 6 slices of pizza out of 0 slices of pizza. I can't give you 6 slices out of nothing. I can't create something out of nothing, right? Part over whole. I could do this. I could give you 0 slices of pizza out of 6 slices of pizza. That's just me being mean and being like, no, you can't have any. It's mine, right? 0 out of 6 is 0. 6 out of 0 is undefined. It doesn't work. It's like an error. Your calculator will say error because you can't have something out of nothing. But you can have nothing out of something. That's someone saying like, yeah, I have 6 slices of pizza, but you're getting none. Right? So these are not the same thing. Make sure you know the difference. Why must the restriction... Okay, so this is why. Because you can't have a value of 0 in a denominator. You can't have something out of nothing. Right? Part over whole. You can't have something out of nothing. And once again, as always, I just want to remind you guys that at the top of your paper there are these nice QR codes. If you download on your phone a QR reader, there are nice little video tutors that you can get to straight from your workbook pages. Choose one of the other specific equations from Part A. Show that the solution of the literal equation gives the solution of the specific equation. All right, so let's look at negative 2x plus 5 equals 11. So if we change this into negative ax plus b equals c, when we go to solve it, we would have negative ax equals c minus b. Then we divide by negative a, and we'd have x equals c minus b over negative a. So here our a is negative 2, our b is 5, and our c is 11, right? A, B, C. So plug it in here. C minus b all over negative a. Bam, bam. 11 minus 5 is 6. 6 over 2 is 3. So I got 3. Well, what did I get earlier in our packet? We got negative 3. So I screwed something up. We need to figure out what. Okay, what did I do wrong? We had, did I write the problem down correctly? Negative 2x plus 5 equals 11. Yes. Negative 2x plus 5 equals 11. Okay. Negative 2, 5, 11. Okay. Minus b, c minus b, divided by negative a. Okay, I agree with that. C, 11, minus b, minus 5, over positive 2. Yeah, but it said negative b, negative a.
Yeah, that's why in the parentheses it's negative.
Oh, because I shouldn't have put a negative here is why. This just shouldn't have been negative, sorry. That's what it is. The a is negative 2, so I can't have negative, negative 2, or it cancels each other out. So just be really careful with that. So when I wrote my equation, I should have just wrote it as ax plus b equals c. Does that make sense? I did the negative twice, because if I put it as a negative a, and I put the value as negative 2, those are canceling each other out. You can't do that. So here it just should have been negative 2, which gives it negative 3, and then I know I did it right. I got the same answer both times. All right, so you have to be really, really careful that when you're doing it literally, that it's still, holding true to your original problem. And when you get something that doesn't make sense, just look back and think and try to figure out, okay, where did I get wrong? I obviously messed up somewhere. Where did I mess it up? We okay? I'm human. I mess up too, right? We all mess up. Don't ever feel like less of a person when you mess up because, it happens all the time and you don't want to get all upset about it. Just, it is what it is. You learn and then you don't do it again. Solve the literal equation. Ax plus b equals c, where a is not equal to 0, and then use the literal equation solution to obtain the solution of the specific equation. So they're giving us this one. All right, so if I'm solving this for x, I can divide by a on both sides, right? So I would have c over a, and that was the division property of equality. Then I want to subtract b on both sides, and that's subtraction property of equality. So this is our equation. Okay? So now we're going to let these be the values. So x equals c over a minus b. Negative 6 divided by 2. Oh, I was supposed to write it first. Sorry, guys. This should have just been, I was supposed to write this here. So c over a minus b. They like you to show every single little thing. C over a minus b. Negative 6 over 2 is negative 3 minus 7. Bam, bam. Negative 10. Okay? We okay so far? When solving, why do you divide the a before you subtracted b? Because it's easier than distributing it out, right? Because it's fewer steps than distributing the a out first, right? Because you could have distributed it and then had more steps, right? You had two options. You could have distributed the a or divided it out first, because you needed to get the x by itself. Write an equation that has the form. Find the solution of your equation using the literal equation solution. Okay, so what about this? I'm going to write an equation. I can divide by 3 on both sides, which would give me negative 2. Subtract by 4 on both sides. So x would be negative 6. All right, I just made up a problem and solved it. Another way to solve a times x plus b equals c is to start by using the distributive property. So if I did that, I would have I want x by itself, so I'd have ax equals c minus ba. Then I would divide by a on both sides. Which would then, so here would be, what did I do? Subtraction. Then division. Then clean it up, which is simplify. Make sense? All right, so I want to skip down to here, to 3. So if I am solving for h, I want h by itself. So I'm going to divide out the LW on both sides. And I would have h equals v over LW. If I'm solving for k, I can multiply by 2 on both sides to get rid of that fraction, right? I'd have 2e equals kx squared. I'm solving for k, so I need to get rid of the x squared, so I'm going to divide out x squared on both sides. And I'd have k equals 2e over x squared. So, this is pretty much everything that you really need to know to be able to do tonight's homework. So once again, tonight's homework is going to be pages 39 and 40. Do your best. 39 and 40. Have a great day.